Hello, everyone. Today I'm going to cover the last set of the derivatives. So we're going to go ahead and start at question number 31. Um, so we're only exclusively using the power rule, okay? So for this product of two binomials, since we haven't covered the product rule yet, so the best thing to do at this point is to go ahead and FOIL this out completely, like renaming it using algebra, and we get this x squared plus 1x or simply x minus 2. And this is, okay, this is the expression we're going to apply the power rule. Okay, to. So what is the power rule for x squared? So its derivative will be 2x plus 1, right? Plus coefficient 1. And then for the constant, its derivative is simply 0. Okay. So right now, you can still use the power rule as long as you rename it, expand it by foiling the two binomials. Okay. What about if you had 32, problem 32, let's say, go ahead and get the derivative of the ninth root of x to the 8th minus square root of 2, x raised to square root of 2. Okay, so here we can express this first term as rational exponent x raised to 8 over 9, okay, minus square root of 2, x to the square root of 2. All right, so this is our new expression. Now we can start the derivative using power rule. So it's 8, 9 times 1 because it's understood. Okay, 8, 9x raised to 8, 9 minus 1 in the form of 9 minus 9. Okay, so we have this coefficient square root of 2. So we're going to multiply this square root of 2 to that square root of 2, which is just going to be square root of 4 or simply 2. X raised to square root of 2 minus 1. Okay. So our final answer is going to be 8 over 9, x to the negative 1, 9, minus 2, x to the square root of 2 minus 1. Okay, if you want to express this using positive exponent, you can move the x to the negative 1, 9 down here at the denominator. So your denominator is now 9x to the 1, 9, okay, and then minus 2x raised to square root of 2 minus 1. Okay, suppose you have to get the derivative 1 over 2x minus 6 over 5 x to the fourth plus 3 square root of x. Okay, so this is like a brush of shortcuts we covered in the part 1 and part 2. First one is reciprocals, okay? So before we apply the shortcut, we can go ahead and express this as 1 half times 1 over x. And then this 6 over 5x to the fourth, we can also do the same. So 6 fifths times 1 over x to the fourth, and then plus 3 times the square root of x. Okay, so this is a reciprocal right here, 1 over x. This is also a reciprocal of x terms, right? And to get the derivative of those reciprocals, so the shortcut that we developed from the first and second part of this series is that, okay, 1 half is a constant, so we'll just bring it down. And then what we do here to use the shortcut is to multiply the numerator with the exponent of x1, so that's 1 times 1 is 1, over x, but you have to add 1 to that exponent 1, so now it's 2. And also the last thing we do is make sure we switch the sign, okay? Now same process applies here because this is a reciprocal. So we're going to multiply the 1 and 4, we get the 4, over x raised to 4 plus 1, so now raised to 5. Okay? and then switch the sign. Now we also have a shortcut for the square root of x. Its derivative is, I hope you memorize at this point, it's 1 over 2 square root of x. Otherwise, it's going to be a tedious process for finding the derivative of square root of x and also for those reciprocals. Okay? So simplifying, we simply have negative 1 over 2x squared, positive for negative times negative. Okay, so positive 24 over 5x to the fifth, and then plus 3 over 2 square root of x. Okay, for number 34, okay, our number 30, let's say we have this exponential e to the x. Okay, go ahead and find the derivative. So the derivative of e to the x is itself, e to the x. Okay, derivative of e to the x is itself, e to the x. So let's say you have to find the d by dx, derivative of 5 e to the x. Now this is a constant, so all you need is bring it down, and then the derivative of e is easy. How about you have a negative 3/5 e to the x prime. What is the derivative of negative 3/5 e to the x? Constant, bring down negative 3/5. The derivative of e to the x is itself, and that's it. Okay. Let's say you have 4e to the 5. What is the derivative? Now, e is like a pi. They are irrational number. Okay, it's like a non-terminating decimal. Okay, so e is 2.71, so on. So those are irrational numbers, and they are constant in this case because e is like a 2.71 raised to 5. So this is considered constant. And what is the derivative of constant? 0. Okay, it's not e to the x, it's e to the 5. Okay, now let's say you have 4e to the 5x. So this is your coefficient here, and that is constant. Okay, so what we do is simply copy that as the derivative because you have this linear function. Okay, so the derivative is the coefficient. All right, how about the derivative of natural x? Okay, from the other video I covered the derivative of natural logarithm. Hopefully you have time to watch it, but if you haven't watched it, the derivative of u is like a function of x, so you represent some x terms. To get the derivative of natural log of u, you simply get the derivative of the u divided by that u. Okay, so in this case, this is the u right here. So the derivative, first you get the derivative of the x. Okay, this is like the u. And what is u prime, or what is the derivative of this x? 1. Okay, over the u itself, over that x. Okay, so the derivative of natural log of x is 1 over x. Another thing we have to remember. Now, number 40, say you have to get the derivative of the natural log of 3x squared. All right, so follow up to that example. First, you get the derivative of the 3x divided by that same expression, 3x squared. And then we just need to simplify this. 6 over 3 is 2. X over x squared is x. Okay, underneath. Suppose 41, we have to get the derivative of the natural log of this by quadratic 5x squared minus 3x. Okay, so what is the derivative of this expression? That's the u. U prime is 10x minus 3 divided by that same expression 5x squared minus 3x. And this is already simplified. Even if you factor out the x from the denominator, okay, there's nothing you can cancel out. Okay, so that's it. Now let's go see number 42. How about it's a combination of natural log x? Okay, what is the derivative? Remember the shortcut we have for square root of x. Its derivative 1 over 2 square root of x. Now, if we have to get the derivative of the natural log of that square root of x, all right, can we still apply the shortcut? Okay, let's brush up on our property of log. One of the properties of logarithm involves exponent. Okay, let's say to get the natural log of x to the n, you can rename or rewrite this as that exponent n multiplied by the natural log of x. So from the exponent n, it becomes a simple coefficient or multiplier to your ln x. Okay, so we can use the combination of these two to make the job easier. So what we do is express this square root of x as x raised to 1/2. Okay, and then you can use the property here. See, this is equivalent to what? 1/2 times the natural log of x. Now you can use what? You can use the derivative of the natural log of x, because this is just constant, and the derivative of the natural log of x is what? 1 over x. Okay, and that is all you need to do. If you rename it by using the property of logarithm, okay, it's actually easy. Okay, let's do 43. Let's say you have to get the derivative of 8 log of square root of x. So this time we have the coefficient of our natural log, okay? And the derivative is going to be from the simpler version. So what we do is rename again that natural log of square root of x as natural log of x to the 1/2, and then use the property of log. Okay, so we can multiply the 1/2 and the natural log of x. That's the property of log. And then simplify this to 4 natural log of x. Okay, now you can bring down the, then get the derivative by multiplying the by 1 over x. Okay, so its derivative is 4 over x. Okay, let's look at question number 44. Okay, let's say you have 4 natural log of square root of x. Let's say it's a fraction 4/3. Okay, one more to make it solid. 4/3 using the property log, we're going to rename that square root of x to 1/2 before we get to differentiate this. And then the property of log suggests we multiply the natural log of x by 1/2. Okay, so this is just the renaming part. Now this can be reduced. Okay, can be reduced to 2/3 because 4/2. So this is reduced to 2/3 log of x. Okay, now you can differentiate. So 2/3 is a constant, just bring down, and the derivative Okay, so our final answer is 2 over 3x. Okay, now for the last 6, we're going to cover the derivative of the 6 trigonometric functions. So what is the derivative of sine? You just have to memorize 2 of them. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Okay, the other part, memorize them easier by using this technique here. Okay, so if we write down secant x, tangent x, and then the corresponding cofunctions of these three, cosecant x, and then cotangent x. Okay, so what I'm showing you right now is a way to memorize the derivative of the other 4 trigonometric functions. Okay, so the direction of secant x is inward, so we're going x. Okay, so both of them are to secant x, which is the center. The same with the cosecant x. Go ahead and point to the middle one, which is the cosecant. By the way, the middle cosecant is negative. Okay, so what is the meaning of this diagram? What it means, if I'm going to get the derivative of x, okay, so if I'm getting the derivative of secant x, it says here it's pointing where? It's pointing to secant x and tangent x. So the derivative of secant x is secant x tangent x. How about the derivative of x? So on the second row, the derivative of cosecant, it's pointing at negative cosecant x cotangent x. So its derivative is cosecant x cotangent x. Now, when you are looking for the derivative of tangent x, so now you're coming from tangent x. Now look, it's pointing at secant x, also another secant x. So its derivative is secant squared x. And then the last one is the derivative of your cotangent x. All right, so look at the cotangent x. Its derivative is going to be what? The product of these two cosecant. So it's negative cosecant squared x. So there you go. We have this as our 46. This is our 47. Question 48 right here. Our question 49. Question 50. And that completes our 50 derivative problems and solutions step by step. Okay, so this ends the third part as part of the derivative series using the power rule. And I hope you learned something from this. And I thank you for watching.